By the word,
What's going on? Is it going live or not?
no, no.
There it's going live. Okay. Man.
You're that bad.
Now I can close this because that's just eating up memory on my computer. And I need to find yesterday's word problems. These bad boys right here. So we had already done. We didn't go over any of these yet, did we? No. Other than just number one, we did together. That's it, right?
Yes.
Okay, that's right. Each class goes a little different, so that's what I was wondering. That. Okay. That's good. That's good. I believe. Why is that not showing up? Okay, well, I'm waiting for people. I'll take care of attendance. Blah 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 blah. I am ready for the weekend. I don't know about you goons, but I am just ready for the weekend. That out of the way. There's that. Click this. No, I don't want that. I think I clicked. You know, you're supposed to get what? 10,000 steps a day. I get at least 10,000 clicks a day with my finger. Easily get 10,000 clicks a day. With all this stupid stuff I have to click on. Okay. Wait a second. I think there's another one of those things today. Is there? HOSA, whatever that was that they went to yesterday. I think there's another one of those today. I think that's where Krista is. I think that's where Stacy is. I think that's where Caitlin is. I think that's where True is. Okay, so Riley's got to hold down this row, and he's responsible for all their answers. There you go, Riley. You want to draft anybody? We got some free agents in here. Okay. This row's good. That row's good, and this row. Okay, what's this? And okay. I think I'm done clicking for a while. Well, hello, Howgie. I think there's papers right there. Wait, you don't. Oh, did you? You don't need these yet. I'm gonna put these back here though, so that you. Well, you need those after this period. What'd you say?
You were talking to me. I thought you weren't talking to me.
Yeah, you need these
Yeah, I'll
after
need
this
those
period.
next period.
So do you want to?
I'll just take them out.
That's what I was wondering. Okay.
Also,
I posted a video.
thank you.
Posted a worksheet.
What are your thoughts about having them live Zoom Monday, Thursday, Friday? Since we're just there with you. Instead of
Oh, you
making
mean
a
not
video.
doing so on? So.
Like telling them, giving them the four times of our class. One is Zoom.
Okay.
After doing one month. You were taking the 10 weeks. Well, I just wish they live Zoom or other.
No, that's true. That's fine. I don't care.
Don't.
No, that's fine. We can do basically what we do work. And
Oh, there's like a block. I got this. Like Brady's the new. That's not.
do it first or 10th period. That's bad for his kid. No, it's not.
No, I got that. Brady has.
But we can.
I literally went there and they told me that.
Brady, you look
I
like
don't
a
look like
Brady.
a Russian.
It's a great idea.
I thought you were.
Okay, enough of this free time. So let's go ahead and I'm not gonna draw any graphs. I'm just gonna do the computations on that part right there. So here we go. So the first thing I need is max and min. So the max height on this bad boy is 14. The min height is what? 2. Okay. So what do I know right away now? I know my value of K. My midline is at 8. Then I know my amplitude is 6. Got 2 of them. All right. What else else do I know? The period on this thing. Okay, now what I do know is that from 1 second to 8 seconds is half the period. So half the period is 7 seconds. So the full period is 14 seconds. That allows me to find B, which is 2 pi over 14, which is pi over 7. Now I have B, boom. And the last thing I have to find is the phase shift. So what is H? On this one, it has a maximum cosine. I'm thinking that if it's going to start at a maximum, and it has a maximum at 1 second. It means I have to shift it 1 to the right. Okay, boom, I've got my values. Write my function. Here we go. What is it? Y equals, it's going to be a regular cosine, 6 cosine of pi over 7 times x minus 1, and then plus 8 at the end. Okay, there it is. So now I have my function. Now I have to use my function and find what's Lexi's height from the bottom of the pool at 21 seconds. So I could, if I wanted, just evaluate this, put 21 in here, calculate it on my calculator. I could do that. I also can just go ahead and do a Desmos. So I'm just going to go ahead and do that fast. This, bring this over here as a calculatorito, calculatristo, Dorito. Make it a little bit smaller. Oh, there we go. Perfect. Right here, I'm just going to type in 6 cosine of 5 divided by 7. Yeah. Times, and I said I want to be 21 seconds in there, so I could do 21 minus 1 in my head and just go times 20. Kick it out of there. I mean, I don't have to, and then plus 8. And my answer is right here, 2.59 or blah, 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 blah. Are you going to paste? Paste it. And that is not what I wanted. Paste. You stupid thing. All right, we got it, 2.59. Are we okay with that question?
Yeah.
Geiger, you had that one? Child's play. All right. Let's do the next one. Here we go. Red fox population for Yellowstone fluctuates with the seasons. In January, the cold weather and lack of food reduces population to 500. Oh, kind of sounds like in January, there's a minimum of 500. And then in July, the population rises to its high. So in July, there's a maximum of 850. And it repeats annually, so it's periodic. Sketch a graph on the data. Nope, not doing it. Determine a model. Okay, here we go. We can do this. So, first thing I'm going to do is find my midline. So the value of K is 850 plus 500, 1350 divided by 2. And what does that give me? 675. I got the midline of 675. Next is the amplitude. So 500 to 675, if I just subtract, is 175. There's the amplitude. The period on this is 12 months, which means that B is equal to 2 pi over 12, which is pi over 6. Got that taken care of now. And then the last part of this is the phase shift. Now, if we treat it like we did with the temperature one we did the other day, the average highs and lows, I would let January be what? 1, right? That's my thought. I could let January be 1. So if I let January, if this is the first month, then my value of H would be a shift to the right of 1. So now I'm going to write this. Now, if I'm going to start at a minimum, though, that means it's what? Inverted. And if it's inverted, that means that A needs to be not positive, but it needs to be negative. So I'm just writing that down for my own knowledge. So here we go. Write the model for this. Y equals negative 175. Cosine of pi over 6 times x minus 1 plus 675. Okay? Good on that one, the function? Owen, got that one? Good. Now, the next part, what is the estimated fox population in the park in the month of November? If I'm doing the month of November for this function, what is x going to equal then? 11. So literally you're just going to plug in x equals 11 and get back some value. Does anybody have what it is to the nearest whole fox? We don't want any partial foxes. 587. Alrighty, there we go. Now would be through using Desmos again. Alrighty. Ryan is riding his bike home from school one day. Picks up a nail in his tire. The nail hits the ground every 4 seconds. Reaches a maximum height of 48 centimeters. Assume the tire does not deflate. Okay, good. So it's sealed around that nail. All right, no problem with this. It says use that. We're not going to do that. Write a model to describe the situation in part A. Okay. So literally, if I think about this, what we have is we have this tire, right? And as soon as he runs over the nail is going to be right here at the very beginning, correct? That's where the nail starts at. It doesn't like get shot into his tire up here when he's riding. So he runs over it. So it starts here. Now, does it matter really and truly which direction this is going? Does it? No, it doesn't matter, okay? So what do I know? It has a minimum of what? What's the minimum height if it's on the ground? 0. And that's at time equals 0. Then it reaches a max up here of what? 48. Okay, 48 centimeters. And that would have happened how many seconds after this, by the way? 2, right? Because it makes a revolution, what, every 4 seconds? So it goes all the way around in 4 seconds. What does that 4 seconds represent then? Period, right? So here's the minimum, here's the maximum, here's the period. Let's do this. We can do this. Okay, so let's go ahead and get the midline K. It's just going to be half of 48, 24. Got it? What's the next thing? The amplitude. Guess what the amplitude is on this one? 24 as well. Okay, the period we said was 4, which means that B is 2 pi over 4, which is pi over 2. All I have left is a phase shift. If it starts on a minimum, I could write it as a what? Yeah, so if you start at minimum, it's an inverted cosine function. And then I don't have to shift it left or right, because that's when time is 0. So I'm not going to even have to do a phase shift. On this one, the phase shift is h equals 0. That's the phase shift. Now, if I started it as a maximum, though, then I'd have to do a phase shift of what? Plus 2, or 2, yeah. It would be a phase shift of 2, so it would be x minus 2. All right, here we go, function. So it's y equals amplitude 24. Is it right? Negative. Why? Because we're going to invert it. Boom. Cosine of pi over 2x plus 24. There it is. Yeah.
Would you kind of incorrect if you just did it as a regular cosine with an x minus 2?
No, that's not wrong.
Okay, and then the last one I had x minus 7.
Well, let me go back up here.
Yeah, I just did cosine and then x minus 7.
You're allowed, and you wrote it as a positive 175. Yes, you're allowed to do that. Correct. Yeah, there's nothing wrong with that at all. That's the same. That's just an equivalent function. Okay. All right. All right. Now we got this guy. So, and I told you yesterday, of course, you're not here. You're starting there instead, right? So draw a graph to model your height above the ground at key points. Okay, so what do we know on this thing? Well, I'm going to write down some things on here. So it says on this, you see it is at some unknown height. above the ground at the start, it takes you 42 seconds to reach the top. Okay, and I showed you it's going this direction. So from here to here is 42 seconds. And it says 30 meters above the ground. So this right here is a max of 30. And the wheel makes one revolution every 72 seconds. Okay, so it doesn't matter where I start that from, but we know it's one rev is 72 seconds. The one revolution is the same as giving you the what? The period. So I'm just going to write down the period is 72. That means immediately I can find B. B is what? 2 pi over 72, which is pi over 36. So I got my value of B already. That's one done. All right. Now, what do we know? Here's all right. So my max is 30. What's my minimum? What's the minimum? 2. Okay, so if we know the max and the min, let's find K. K is going to be 30 plus 2. 32 divided by 2 is 16. Got that. That's good news. I can find the amplitude then. The amplitude is 14. Got that. All right? So here we go. Now I have to decide how I want to write it. It's all about my phase shift on this. This spot right here, that is when t equals 0. Unfortunately, that's not a minimum or a maximum. This right here, okay, because it's going this direction, I would like to know this value of t here. This is what I'd like to know. What is this value of t? Well, how do I do that? A couple ways. If it takes 72 seconds to go around once, that would mean that from, where's my pens, my highlighter, that would mean that from here to here would be 36 seconds. And we know that that other part I highlighted already, this entire thing we said was 42 seconds. So this little piece here has to be the difference of those. So that means that this little piece right here, this piece is 6 seconds. Now what does that tell me? It's 6 seconds to shift it over to a minimum. That is the phase shift. That means if I was graphing this, 1, 2, 3, 4, 5, 6, here's where it would be at its minimum and start going back up. That graph would start going back up like this and come back down. That's where I want to start my graph at then. That's the phase shift, 6. So H equals 6. All right, so now we can write our function. Our function will be y equals, since I'm choosing to start it at the bottom, it's going to be an inverted. So it's going to be a negative amplitude, so that's a negative 14 of a cosine, pi over 36 times, times x minus 6, and then the midline, which is the plus 16. Okay, now, Miss Ford, I'm guessing you did the same thing on the other ones. So here's what you have. Miss Ford might have y equals 14 times the cosine of pi over 36 times x minus 42 plus 16. Is that what you have? What? You tricked me this time. Because this is doing what? Starting it at the maximum. And if I start at a maximum, then it's a regular cosine, so I don't want a negative a, I want a positive a value. Same thing again, same option. All right? We okay with those? How do we feel overall? I want you to put a score on your paper, like out of 10 again. How are we feeling about this? How are we feeling? Are we on a 1 out of 10? Are we a 10 out of 10? If you're a 12 out of 10, thank God. It'd be wonderful. Okay? Let's see what we got here. That's not bad. I can handle that. That number there. I thought it was an L. Whoa! 25? Sam's a 25 out of 10. Okay. 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 Right. Okay. Okay, so let's head into our next set of problems. So here's the deal for today, okay? So there's 2 different worksheets you're going to get today. The first one we want to get done in class and go over. Okay? The second one will be your homework for the weekend. And the homework for the weekend is just one word problem with, like, you have to go ahead and do like the little steps underneath it as well. So it's one word problem with just like multiple things below it you have to do as well. So here we go. We're going to give you this one to start. And then I'm going to tell Sam, who had a 25 out of 10, Sam is going to tell me which of the front problems he wants us to do together first. Sam is going to tell me that with this 25 out of 10. Which problem he wants us to do first together. So let me go ahead, Sam, while you're thinking about that, I need to get this up on the old Smarty board. That is not it. Where's it at? No. It's somewhere here. Whew. Let's print this. Sam, which of those problems in the front would you like us to look at together? Notice, by the way, I didn't leave you room to graph them. And again, it says to graph the function. You do not have to sketch the graph of it. That's completely fine. You can just go ahead and do everything without that. If you want to sketch one on your own, you could. But I'm not expecting on these that you do some fancy drawings. Okay.
How many am I picking?
1. So you can choose 1, 2, 3, or 4.
Let's do 3.
3. Okay, we're going to do number 3 as soon as it shows up on my board. He did. He wrote 25 because he's, you know, that's just Sam. Sam's a wild man, I can tell. Ty's laughing about that. I say Sam's a wild man. Ty's like, I love it. You know who told me you're a wild man? Mrs. Howdy's sub yesterday. Miss O'Hara. She said, Sam's a wild man. That's what she said. I said, well, I'll have to take your word for it because I haven't seen that in class. I said, it's pretty quiet in class usually. Okay. Here we go. So we're doing number 3. The old submarine is on a training exercise. I love this problem. So it's on a training exercise. It says, during the exercise, the captain wants the vessel to porpoise underwater. So that basically means that they start going down and back up and down like a porpoise would swim like this. That's what they're going to do. So they don't stay at a constant depth at all. It says, during the exercise, the following data was obtained. All right, so time. 20 minutes into this exercise, they're at negative 50 meters. 50 minutes into it, they're at negative 90 meters. 80 minutes in it, they're at negative 50 meters. 110, they're at negative 10 meters. And at 140, they're at negative 50. So I'm looking at this. So if I were to go ahead, I'm just going to sketch this one real fast. I'm going to sketch it. I'm not going to draw some fancy graph. This is one of those that's a little different because I'm not in quadrant 1. I'm actually in quadrant number 4. Is that right? Yeah. So this would be like, here's negative 10, negative 20, negative 30, negative 40, negative 50, 60, 70, 80, and negative 90. There we go. And then these are the seconds. 1, 2, 3, 4, no, these are minutes, we'll say. They're 10 minutes apart. So that's 10, 20, 30, 40. So if I did this at 20, this is 20 right here, I'd be at negative 50. 1, 2, 3, 4, 5. At 50, I'm at negative 90. I'm way down here. I'm at 80 then, that's 50. At 80, right here, I'm at negative 50. At 110, I'm at negative 10. And then at 140, right here, I'm back at negative 50. So it looks like this. They're going, all right. I like that. That's a good little sketch. I like that sketch. So what's my maximum? This is where you gotta be careful because for depth, you gotta be careful here. Yeah. Negative 10 is my max. So think about it. Even though that's a negative number, negative 10 is bigger than negative 90. So this is my max at negative 10. Is negative 10. My minimum is at a negative 90. So now I can find my value of K. Add them up, you get negative 100. Negative 100 divided by 2 is negative what? Negative 50. Do you notice that this right here, oh, so those values I gave you were actually the what? Midline values. Now, what's cool about that is that means I could write this one as a sine function pretty easily if I want as well. I can do this one as sine or cosine. Either way, it's not going to be a problem. All those other ones I was doing was almost easier to just do them as cosine functions, it seemed like. This one you could do either way. All right, so there's K. Boom. What's A? 40. So now I have that. Got it. Good. Okay. Now I need what? The period. What is the period of this thing? From 20 to 140 is how many minutes? 120 minutes. That means B is 2 pi over 120, which is pi over, boom, got it. What do I not have? H. All right. What is H going to be? If I choose, Mr. Snyder says, well, when I'm looking at this, I'm looking at this, and that's what I'm going to write it from. That right there. What is H going to be for my yellow graph? Geiger. 20. It's going to be 20. Okay? So I'm going to have H equal 20. All right, let's write this bad boy then. Here we go. What do we know? It's right here. Y equals. Since it's going down first, my value is going to be what? My A value? Negative. It's going to be an inverted sign. So it's going to be negative 40 sine of pi over 60 times x minus 20 plus, not plus, and a minus 50 at the end. Okay? There it is. We got that one. Then it says determine an equation. We got it. It says approximately how deep the submarine is when the training exercise began. How would I do that? At what depth was it when the commander, okay, let's say the commander of the submarine said, we're going to start porpoising starting now. And here's what he tells them what's going to happen. What would be their depth when they started? Let me go ahead and get a graph up here. So here's this. Let me enter in our function. So we got y equals, I can't see it all, negative 40 sine of pi divided by 60. And then x minus 20. And then we said it was minus 50. Boom, there it is. Here's the porpoising movement. So where am I looking at on my graph? I'm looking at the y-intercept, right? That time equals 0. So I would just come up here, boom. So they started, this whole thing started at about negative 15.359 meters. Okay. All right. Any questions on that one? That was a good choice, Samo. All righty. So we did number 3. So basically you have 1, 2, 4, and then on the back, you're going to do this one. Let's read this question real fast together before I let you start working on these. These are the ones we want to get done in class, okay? Brad and Jimbo go to ride the Ferris wheel, the Wheelin' Keelin'. It's also at the Function Island Amusement Park. As riders board the ride, they are allowed to electronically vote for the speed the ride will rotate. That's pretty cool. Which it announced after the last rider boards. Brad and Jimbo hear the ride attendant announce that the wheel will be set to make one rotation every 52 seconds. The wheel has a diameter of 78 feet. Passengers board from a platform 6 feet above the ground. The ride starts as soon as the last passengers are secured, and it takes 14 seconds until Brad and Jimbo reach their maximum height on the ride as the wheel moves counterclockwise. Write an equation. And then it says from the time the ride starts, power goes out 3 minutes, 48 seconds into the ride. How high above the ground are Brad and Jimbo when the ride stops? Part C, for each revolution, how many seconds are the two boys more than 38 feet above the ground? And then the last one, at midnight, this is the challenge. At midnight, Brad and Jimbo go ride the Ferris wheel again. Midnight is when they turn the Ferris wheel to max speed. The attendant announces the passengers will rotate at a linear speed of 8.35 miles per hour. Write a new function to model their height during the ride if they are the last boarders. Now, the big difference on this is that I did not give you rotations per or revolutions per minute. I didn't tell you how many seconds it takes to make one revolution. You have to figure that out from the linear speed I've given you. Even though they're traveling around in a circular fashion, their position still has a linear speed. You will have to find out how long it takes for the Ferris wheel to go around once, knowing that the linear speed on the Ferris wheel is 8.35 miles per hour. That's the challenge, is getting to that part. Okay? Otherwise, once you have that, the rest of it's just like the other problem. There you go. We will go over these today, and then I will give you the problem for the weekend, which is the super duper crazy challenge that Sam said he wanted. And I said, no problem. So we'll do that afterwards. Okay? So go ahead and work on this one. And yeah, there you go.
goes from.
Well, it's 6 hours, right?
Yeah, but I didn't know if that'd be added here because that's from max. So I think you have to go another 6 hours. I'm not sure. I think it's 12.
What if it starts in
No. So it starts at
exact years to suppose that's because its tone is higher. So it starts at a maximum, right?
yeah.
And
And then
it
it's
will
saying
be,
6 hours is the minimum. So you need another 6 hours.
so 12.
So 12. So
So then we just 5 and 6.
yeah. So then each is just 0. Oh wait, 8 is 0. It's 0. It starts at and then 6 hours. Then 5 times. So those. Yeah.
So given if all the times that the depth will be 6.
That's the maximum.
Hmm?
Wait. Yeah, that's the maximum. What's your
Because in the
I'm sure it's looking plus it, but it is under.
let me just see.
Or no, it's not. It's saying the lowest.
Yeah, yeah,
No, yeah, here. Yeah.
it's not excellent. I think what we have.
Yeah.
Wait. So then, what would the depth be? 4.
Yeah, so it's starting now. So it's saying give all the times that that will be 4. So you just go over. That's a minimum. So it's just after 6 hours.
What do you mean?
I just got 6 hours. At 6 hours. After 6 hours.
Oh, yeah, that's right. Oh, I didn't.
Is there another?
Because the next one's 18.
Yeah, but that's like another.
That's another. Yep.
Yeah.
6. That's why I said I saw give all the time.
Yeah.
I was like, okay. Warfare's highest crown is 50 or 99. Each above the station. 21. Assume that it starts as soon as you see. You start one for
Yeah, so you start at.
and you're 99.
So there's.
above
Yeah.
it.
So that's the. So, I mean, midline is 50. Right?
Yeah, because it's 1 plus 99.
Yeah, so K equals 50. Amplitude is 49 then.
Yeah. B equal to pi over 50.
Wait, it takes 30 seconds. Wait, how?
That's one revolution, right?
Yeah.
So that's one thing. So it's just pi over.
So it'd be 2 pi over
2
8,
pi over 3.
which is pi over 15.
Yeah.
Oh, okay. You said pi over 50. So
Oh, my bad.
No,
I missed. Yeah.
pi
I
over
have
15. And then h is 0.
No, it's just saying
Well,
that.
no,
So
but
start-
you start one for the
water.
so h minus 1, right?
No, the feet is the watt. The h value would be the time. So yeah, you start at like 0 seconds. Because you're starting at the very bottom of the periscope.
Yeah. Like,
You're
oh
just
yeah, because we
starting-
have that.
yeah.
Or what we.
So then
So then would it be sine?
it'd be y equals, well, you're starting at a minimum. So it'd be negative cosine. Inverse cosine.
Yeah.
So negative
Well, what happens if you put a negative?
49.
It's the same graph, but just below 0. So I'm kind of thinking that either way is kind of. I'm gonna provide it for you, Riley. I'll do the same. It doesn't, I don't know. It doesn't say though.
It's the same graph. It'll be at 4 feet.
Okay, yeah, we did it right.
Yeah.
Compared to.
And then determine after an equation if you're by at least 2 minutes for 2.25 minutes. How high will you be?
It says when it's at 4, I mean, it'll be infinitely at 4.
Wait, what's his name? Oh.
But I just, it'd be like.
I said it's 6 hours. and
It's
18
around
hours.
You're 2 minutes in the right. 2.25 minutes in the right.
So this is in seconds, right?
Oh yeah.
So
Which is how many seconds?
that's
Times 60.
120. That's 108. Oh, and a quarter.
Yeah.
That's 100 and
Well, you got it.
You're at 99.
150.
It's 2.25 times 60, right?
Yeah.
Yeah.
0 hours.
And then it says you're at
No,
30.
0 hours.
It says you're at a maximum.
Yeah.
So,
90.
so that'd be
You're 99
In
feet.
6 hours, it'll be low down. So it's positive.
wait, what is it?
No, I understand.
Oh.
Oh yeah, yeah. It says you're at the max.
Yeah, because you're at the max.
Yeah, or so 99 feet up.
Yep. So,
I'm so hungry right now. I need breakfast.
I gotta have glass of milk.
Okay, we did the summary.
a glass of
Just a glass of milk.
I would be like, Jack is gonna hold
Morning is a good day.
Why do you have a cold? Why do you have a cold?
The water level is 6 meters above average
like,
sea level. So it drops to 6 meters below average sea level. Right, it's like
He threw it on the floor.
every
So
12
where do we
hours.
start at? Do we start at 0?
Yeah, you start at 0 because that's just,
Okay.
and it goes up 6 and down 6. So
So
this is gonna be a sine.
No, they look.
yeah, because the midline K is 0.
Yeah, and the amplitude.
Amplitude equals 6. B would be pi over 6. And then we don't have any shift, do we?
No, because it starts at 0, 0, right?
Wait, it's asking
They were, I had
draw a
No,
graph.
not for his phone, for his computer. Oh.
Wait, low tide? What does this mean? It says assume that low tide, the depth of the water is 2
Hey, if you had
meters.
the new Chromebook, like me.
No, that's the next question. We're just trying to find a
You
function,
never charged.
right?
But it's not, is that even?
No, this is the graph for it.
It's actually just smaller.
This is for the graph.
Doesn't fit in my phone.
It's saying, so write it for the next 24 hours, so 2 cycles. And then it's saying,
Sounds.
assume that at low tide, the depth of the water is 2 meters.
We talk about.
Oh, so it's saying
Yeah,
the minimum is 2 meters. So the midline would be at 8 meters.
So 4. Wait a minute, right?
8, I think, because it'd be 6 plus. Because it's going 6 down.
Oh, it's going 6 down.
Yes. Why would you pick that one?
So
That'd be
the
4.
minimum is at 2 meters above.
Yeah, you should have picked number 2. You should pick number 5.
So then to get back up to the midline, you go plus 6, right? Or is that saying we're just starting at when it's 2 meters?
No, the low.
Yeah, because right here it says the low tide is 6 meters. Or no, it's just saying it's dropping 6 meters. It doesn't say.
Back down.
It doesn't say what it is. So look. So it's saying the low tide. So say this is the ground.
La 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 la.
Starts here. So this is
There's the bell. I made it on time.
up 6 meters to get to the midline, and up another 6 meters.
What?
I think.
Where does it go up?
It is.
No, because it starts at 0, 0. High tide, 6. And then goes back to the regular tide. And then goes down. Because it's a sine. It's a sine curve. Because then it goes low tide. And then it comes back up to the regular tide. That's the regular.
Oh yeah, we don't. That's not saying we're starting there. That's just saying when we get to low tide.
Yeah, then draw a graph how the depth of the water changes over the next 24 hours. Assume that the low tide, the depth of the water is 2 meters. So low, it would be under 2 meters, the regular. So it'd be then -2 to 6, right? -2 to 6.
Yeah.
If you were the last one, that was question you would have to start at the bar. In the picture, it gives exactly.
So that would be a minute.
So that is
Right.
2 meters, and it's saying at 6 meters below average is the low tide. So the midline would be at 8.
And it's 6 meters above average sea level, and you drop 6 meters below average. Okay.
So the minimum would be.
Oh, yeah, so this drop is 6 meters.
That's just saying it's coming down.
That's getting me to
Yes.
That's the answer is above and below.
So then the midline would be 8, and then the max would be
Correct.
14.
Right, that's what it looks like, yeah. Yeah, but
What is it?
So we're starting at 0 tide, but
What exactly were?
it's saying
Oh, wait.
Start at 6, and then it goes up to.
A's 49.
no, it's saying the minimum is 2 meters.
Okay.
This is just saying it's dropping 6. So it's saying it's dropping 6 from the midline to 2 meters. So the midline has to be 8,
Oh, okay.
and then the maximum has to be 14. I think we do still start at.
yeah, so it really doesn't. It'd be up to
We
you.
still
I would just
start.
say
We still start at 8 meters.
That's what I would do, because then you don't have to worry about doing.
So the equation would just be, so that just
Correct.
changes the
Basically.
amplitude, the
Right.
but the midline, K equals 8.
We're gonna do the answers to all
And then
of them.
H
I probably won't sketch anything.
So it's
I'll
just
tell you
A8,
the answer to the
A6.
question.
Yeah,
Ask you
so
to
the
the
equation
answer
is
to
the
the,
sine.
like this
Yeah.
part here, and then we'll
Yeah,
see if you
the
have questions.
last one. I mean,
Okay.
you start as
That's not saying we're starting at 2 meters, is it? That's just saying our minimum's at 2 meters. We're still
Correct.
starting at the mid.
Correct, it says, yeah, so.
2 minutes and 15 seconds. I got 5.8. I'm gonna do it myself.
I'm gonna tell us.
You can start wherever you want on this one.
Oh,
It didn't tell you. So if you want, you could make it so the midnight is this, and you can make the midnight midline, you can do.
But like if there was 0 phase shift, where would it be? The midline?
If there was no phase shift, and you were starting at average, that would be the midline.
Yeah.
Oh, see, I knew it.
Okay.
We had to predict.
Yes, it would be a sine.
Yeah, so. Well, yeah, but then this says 24 hours.
Oh, yeah. it is.
So that changes the period.
15 seconds.
Yeah, you're right.
So then
So
it's
this is
high
pi
hour.
over 12.
Yeah, instead of 5.
So that would just be, so 5 over 6.
It would be 101. Yeah.
So this one here.
Is it at the very top? So we definitely.
Would this be Y? No, X. X equals.
Oh, the question?
Yeah.
was the depth of the water. No, that'd be,
They're letting
well,
the
yeah,
other
that'd be
guys off
y
first,
equals
and you come
5. Or no, 5 p.m. Sorry.
No, because I think,
I don't know.
You have to type in x equals 5 and then see where it is.
yeah, 13.7.
In one area.
13.8.
I did it when we were doing it. I copied down the equation. And I from the what? From 3, the one we did on the board, the last.
I think that's right.
I didn't grab it.
Oh.
I didn't. Well, I mean, I got it on this. I grabbed it.
This one, I'll make that down later.
It's another one.
Yeah.
This one's right.
I have a what? I do not have any. Somebody, mine's missing the one I had. What happened to it?
I don't think we did.
Picture brightness is 0. Then it's
What?
I don't think the period changes.
Well, yeah, because that's just over the 24 hours.
Yeah, no, that's just saying 2 graphs. Like, the period's still every 12 hours, so it's still pi over 6.
It's
one or the other.
And it'll just be x equals 5. 5.
What comes out as a number? A letter.
Wait, what time?
So K is 0.
So this is
And then A equals 6.
When you start at 1 o'clock.
A equals 0, B equals
Is
5.
Oh?
And then H is E is 0. Wait. One cycle is completed.
Yeah, I don't know what.
Well, if we do whatever we did,
A and H is 0.
Let's just start it.
It doesn't
Yeah, it
matter.
does say round to the nearest hundred. I'm guessing it's a decimal. We're going over it.
it's either 13.8 or
Assume that at low tide, the depth of the water is. Oh, okay. Yeah. Not like. So that means that it's 2 meters to 8 meters to 14 meters. So 8 K. Or the high tide thing, rather, the high tide thing is like, it's the depth of the water. Probably like, so like, it's, where are you getting? So it's like, it's 2 meters. I'm not right at 6, because that was below. Where did you get 2 meters? Literally part A, yes, part A. It says. Wait, so K is level is 0. Bro, it's talking about the depth of the water, not how high it is. Yeah, so basically. So like how deep it is. It's basically the information they give us. Like a pool is 12 feet. Like a pool would be 12 feet deep. So like if we get it, it'll be a sea level off of the 12 feet. It's just right between the two. So it's saying that okay, let's do it. No, it says at low tide. At low tide the depth is 2. So then it's 8 in the middle. And then 14 is the high. At low tide. Yeah. Then you have to go up 6 would be the middle. And then up 6 again would be the high. But I don't know. The A is 6. A is 6. We know that. Yes. And then so like the low. I don't understand it too. I don't understand why it's giving us the information. Yeah. It didn't give us any information about it up there. It did. It gave us the internet.
Wait, so how do we find
It didn't give us the linear max. It gave us the A. It's 6. That's the A. Is right. Yeah, but they didn't give us where it started. But it's A equals 0? Bro, I'm just doing it. Yeah. I'm just doing it. It's a negative cosine function. And they get it. I'm gonna show this to Mr. Stagger and he's gonna say, like, Jim Stagger. What problem are you doing? That's what he's doing. What? Yeah. What?
One for A. Because A is a different.
What are you talking about?
A is a different equation. It's different numbers.
Yeah. But it's tight.
Bam.
So you basically just ignore the whole topic.
I didn't. There was nothing to ignore.
There's nothing.
Is this right? Oh, I just didn't negative cosine.
It might be the differentiator.
So basically, I got it right.
Wait, what did you have for the H?
0.
Well, then it has to start at the midline.
No, it's at.
Because it's not saying it starts at 2 meters. It's just saying the.
Yeah, it does. It says at midnight. Oh, the average. Okay, I got it wrong. But I know what I'm doing.
You got it wrong, but you knew.
The water is average at sea level.
Yes, that's what I was saying. So
So it was in the middle line with the sign. So that the top would be 6, and the bottom would be 6. No.
Oh, that's how we figure it out.
No.
So at
I literally
midnight.
have to say that.
Yeah, what if you're acquainted with that?
So if
It
it's
is.
5 p.m.,
Why the 6 sign of
that would be x
over
equals
6 x plus 8.
literally.
12 plus 5. So 17.
Why is it 6 sign of 5 to 6 x plus 6?
Yeah.
It's the same thing.
I just thought
2.2 over.
below
Because it's not just x equals 12.
Oh, you did 12 of that. No, you're
Or no, it's pi over 6.
Yeah.
Yes, that's what I'm saying.
So the middle of the 8.
So you still get 11?
Yeah, because it's the same.
Because it's just adding
It's-
another
it's-
cycle.
That's a whole new cycle.
Okay.
It's the same cycle. Same thing, it's just further down.
Yeah.
Wait. Yeah.
Have you started this one?
No, not your decision.
About to say.
Okay.
No, it's fine. You can study.
Alright. As writers, they are allowed to. Rotation every 52 seconds. So well, we can find
Oh, wait.
B right now.
So period, yeah. So B equals 5.
Start at the
2
top.
pi over
So
52.
it's pi over
I just like
It's
said,
that'd be
I gave my.
31, no, 20,
Over
26.
Yep. 1 pi over 50. Or
26.
It'd be 11.
I just don't get how we're supposed to find out. Because it says it makes a rotation every 52 and the diameter is 78 feet.
Okay.
It says it takes them 68 or 14 seconds to get to the top.
Where do they start? Like on the ground?
No, we don't know where they start. That's what we have to figure out.
Well, no, but no. Where is it? Like on the ground?
It's 6 feet above the
Like
ground.
it's here to here, right?
Yeah,
Diameter's what?
78.
And then up one more.
Up one more.
Because that would be the top. From that to 0. Well, actually, I don't know.
It'd be up 6 more because it's 6 feet above the ground. Oh, so the very top
Like, is it 6 feet from the ground?
Yeah, the bottom. Like they bored from 6 feet above the ground.
Yeah.
So the Ferris wheel is 6 feet up. So then the maximum is 84. So the max equals 84.
Did you get 11?
Wait, but
Isn't
No, diameter, well, radius is 100.
okay, yeah, you're right. 78.
So max is 84. Minimum would be 6.
We're trying to get it to,
So
we're trying to get miles per hour
midline is
to,
90 divided by 2,
45.
which is 45.
so, yeah, we would
Which then the amplitude would be
84 minus 84.
39.
Yep, 39.
But now we have to find 8.
Is the basic start mile per hour? No.
Because we don't know where they
Because it
start.
starts at like, it's like the other one, that we like kind of
6
freaked
feet,
out over.
right?
No, it's not saying this. So basically they board at 6 feet and then they go around until everybody's on.
meters a second.
So it takes them 14 seconds until Brad and Jimbo reach the reach the 84 feet. So if they were to start at the very bottom, it would take them half of 52 seconds. So they don't start at the very bottom.
So they start a quarter way up.
Is that what? Wait, 28? No, not a quarter.
Well, from a min to a max attack.
Half of, yeah, the period.
Yeah, okay, yeah, that doesn't.
So if they were to start at the
So
bottom,
I think they start. I think they start here. They go up. Boom.
39.
What's 52 divided by 4?
divided by 4, it's like 28 or
It's 13.
13. So it's almost.
So they're almost.
Wait,
they're,
52. So it's almost a quarter, but we still don't. There's some way we can figure it out.
wait, can we just take a quarter of 78?
That's the feet.
We need to find that little. The red.
It's really, so like they board here and then everybody else boards. And then they're up here somewhere. And then it takes them 14 seconds to get to there.
Yeah, which is about a.
Yeah, but we have to figure it out somewhere. Like, I don't think we can just do it off like a quarter or half. There's like some.
Yeah. Okay, so I don't need. Right. Oh, yeah. I don't think about it. Yeah, 14. Seconds. Your shift is 14 seconds. So just, if you were graphing it, right? At 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? 14, you go to mathematics. Then they're going to do what? Start going down. You're gonna just shift it over.
So we're just starting.
They're not starting there, but you're gonna write the function based on that position. That's how you write it. No, you do not.
So then it's just H equals 14.
H is 14.
Yeah. Because we don't even know the position.
So now it's a sine. Right?
We're starting.
Right sine is for equation.
No, it's wait. So we're starting after 14 seconds.
Let's just try to write it as like what?
Yeah, no, we'd be out of math, so it'd be a close.
I think you are.
Yeah, but then it says right sine.
No, the sinusoidal equation just means the one of those equations.
Oh, okay. Never mind. 39.
No, why are you not because it's the very thing we did. I don't know. I don't
Pi
know.
over 26.
Because graphic. I said it. We graphic. Then why did this one
X minus 14.
This one over? Yeah. Okay.
Plus
Why does
45. There.
I mean, what's your equation? I don't have one. Well, I do have one, but I don't know how. For 5 or 6. I think we got the same. Y equals 39 from, no, I didn't have it 39. Yeah. Was it 30? That's what I'm doing. Was it 30? There's no way. Because it's actually, they always just talk to yeah, you have to do the 6 plus this. You know, it's much that it's raised up. No, the amplitude isn't affected by this. No, the amplitude is
Yeah,
not.
so this is saying, yeah, 14, we're at 84.
Wait, what did I do?
Which is right. And
No, the amplitude is 30.
Why are you just?
Okay, yeah.
Because it's 6 feet up. No, because the
From the time
diameter
the
is
lights
the same.
on.
And if you start in the middle of.
Like, you don't do anything with the 50.
Starts in seconds.
If you, like, if it's a platform for
3 minutes and 48
you got like.
seconds.
So they would, but here's the ground. There's the middle of the same thing, yeah.
200 and
She was
one,
like,
two,
no matter.
three.
But you know what I mean? So if it's the six feet, so if it's 6 feet there, then that's okay. But if then they start here, 6 feet above, I mean,
Only even like, they're looking at things.
I know, because you need to know where they start. Well, first, yeah.
8.35 miles per hour.
Okay, so 139. So A is 39, A is still.
Yeah.
What?
I mean, I just.
Oh, wow.
Yeah.
Wait, so what are we doing now?
I don't know.
It doesn't make sense. I'm telling you, you shouldn't be. That's your.
But
The deep perspective
So
did not have
stupid. So plus 45.
We're seeing how, or,
That's why.
yeah, did you
You know
get
what?
it?
We write
I just
very-
What, the equation? Okay, so then we had to find after 3 minutes and 48 seconds, but it's in seconds, so you can convert that, so that's 120.
Beyond 20.
Not 120, 200.
Or I guess we divide it into one rotation. That's slightly 41. And that can give us. the rest.
220. So you do x equals 228 and for that.
What'd you get?
74.1.
This starts at the bottom and then.
And
I don't know.
for each revolution, how many seconds is that? Above, more than 38.
Oh, I did it backwards. I said.
So be y. Or has to be.
So I just did y is greater than 38. So they're starting here and they're above it the whole time. Once they get to 28.494 seconds, they get below.
I think it's
But
different.
x equals
Yeah, I did.
No, yeah, one repeat every 50. Yeah. I see.
Then they go back up.
That's ridiculous.
But.
Wait.
I don't know if there's a-
How many seconds of the is more than 38?
Yeah,
They should start.
28? No, but there's like multiple. For each revolution,
yeah. So I think it's just, yeah.
I think it's 28.94.
Yeah, no, so one revolution. No, it's a little more than that. It's like so they're starting here. So is this a sine wave? So they start here, they get to a max. Yeah.
And then they're above
And then
it,
they get back down. Yeah, you're right. So it's just that.
Yeah. so it'd be 20.
28.4.
I feel like if you went like, I think if you went like.
And this next part.
I think I'll get like.
More speed into radius.
Maybe it's not as bad as it seems, right? Like.
Well, I guess it all. Well, we're right too, because it's half of
Well,
50.
because.
It's half the ride to above. That makes sense, right?
Going to use all
Wait,
right.
wait.
Because you start here, you're up, above,
It
above,
is,
above,
yeah.
and then you get to that point. Yeah.
Yeah, it'd pretty much be half, but they're starting.
Yeah, we're close.
above.
Yeah. I was just
So like it's a little shorter.
Yeah.
Yeah, you're,
yeah.
How does that work? Yes, because we know it. I can agree. How does because the 800? Okay, once how is it? I don't know. I don't understand it like.
I think we. Okay, so feet per second, that's 45. Regularly, it's like 3.2 miles per hour. So that would only be like.
I still think. Yeah. Yeah. Right. But it's not going to be 60. But I don't know. Yeah. That's it. You on the ground.
So that's only like.
I don't know. Yeah, but you're tires so yeah. No, exactly. You don't need to figure out. That doesn't mean.
Okay, then you're only doing like 100 I think the older. Yeah, because instead of doing the miles per hour to feet per second, I do the feet per second miles per hour, you get like 3.2 miles per hour. And then so you put that, and you drive that for the 5 miles per hour, and doing the 5 miles per hour. And then you get like 20, and then you do, and you get like 2.6, and then you get about.
Yeah.
Is
Right.
right.
39.
No, what did I do? Oh, right, yeah, you have to put it over 5. So. Yeah.
I think that. This is what this is 70. This.
I don't know, I might actually go back. I don't know. I'm gonna put the other. Yeah.
That's what I did. So they're going to do.
That is
Right.
12.2.
One rotation.
Okay.
All right.
That is, that's how they It's so close. Exactly. So this is gonna be. How is this? There's a cross.
All right. So how is
It's in miles per hour. I don't know if we could convert it to radians, but I think it's
So you go, no, I'm just gonna write down the functions for numbers 1, 2, and 4 real fast.
So, I think we're back at. So, I don't know what we did the whole time, but by double checking the number take down. Okay, so I started here. I did it like the other one.
That's all.
You guys okay with the first one? Again, yours could be a phase shift if you wanted to, but
Yeah.
What did I say?
if you don't have that, if you want to ask a question about it, we're gonna do this individually. Number 2.
Oh, yeah, everybody got those too. Why not? That's silly of me.
No, I'll come. No, I'll turn down. Let's do it fast. Let's see here. 1 foot off the ground. 99 feet above the ground. So we've got y equals, we've got our midline give you 50.
Didn't even write that.
Amplitude of this is going to be 40, is it
Yeah, 40.
feet or 100? This is 49, is that right?
Yeah.
Yeah, that's right. 50 minus, okay, that's right. 49, and then let's see here, it takes 30 seconds. 5 and last one, it starts as soon as you're seated, so you're at the bottom of it, so there's no phase shift, that's nice. You're starting with minimum, so what, negative 49 cosine of pi over 15x plus 50. You okay with that? Hopefully. Like if you start here somewhere else, it could be different, but the negative 49, the 50, and the pi over 15 have to be the same. Okay. Let's see here. Number 4, y equals 6 sine pi over 6. Oops, pi over 6x. Yeah, so let's see. So any quick questions you want to ask on those functions? If you have the right functions, finding the other parts of the questions are just looking at using the graph. Anybody have any questions on any of those 3 functions? No? That's good. All right. I hear a lot of you, I think a lot of you are still working on, I don't know, most of you have at least the first part of this 5A done.
Yeah.
You think you do, a lot of you? Yes. Okay, so let's go ahead. Here's what I have. So I've got y equals, and I wrote this as a cosine function starting at the max height. So I have 39 cosine of pi over 26, x minus 14 plus 45. Anybody else have that? Good. Great. Okay. Any questions on that particular part? No? Because, again, on this Ferris wheel, it takes them, this part right here, where's it at? Right here. It takes 14 seconds until Brad and Jimbo reach their max height. So think about the graph from this standpoint. At 14 seconds, they're at a max, and then they're going to start going back down. So I'm going to write it as a cosine curve shifted 14 seconds to the right. Does that make sense?
Yeah.
So I'm going to have to do an x minus 14. So whenever I give you the amount of time to get to a location like a max or a min, that's telling you the phase shift. That amount of time is the phase shift. Yep. Okay. All right. So on the bottom, down here, are we struggling here? Okay, so here's what I'm going to tell you have to do. Your goal is to find out what? Revolutions, how many revolutions, or how long it takes to go one revolution. That's what you need to know, right? Because you have to know, like up here, I told you it goes one rotation every 52 seconds. So you have to figure out how many seconds is one rotation, correct? You need to know that. I'm going to write it like that. So you have to know rotations. You have to know the number of seconds it takes for one rotation. That's what you're trying to find out. That's the big question here. How many seconds for one rotation? Okay? I'm going to tell you right now, you need to take that 8.35 miles per hour, which could be written like this. And somehow get to seconds per rotation. that make sense what I'm asking you to do? It's a conversion. It's a conversion. Now I'm going to tell you right now the easiest way to do that, because this is what I gave you. The easiest way to do this is to, this is okay. You can say this if you want. Oh, in 1 hour, I go 8.35 miles. If this is true, this is also true. You want to convert this to that. That's all I'm going to tell you. All I'm going to tell you. It's a conversion. If you're in chemistry, okay, and you do the railroad tracks, and you start converting, that's what this is. This is all about converting from hours, trying to get into this. That's what you have to do. And it's just multiplying by equivalence. You're changing it. So I'll get you started on the first one. Here we go. Okay, so guess what I'm going to multiply this by? I'm going to multiply it by 1 mile is 5,280 feet. The miles cancel out, so now I'm in what? Hours and feet. See it? Now I'm going to be in hours over feet. I could do it again. So, and feet's probably what I want to be in. So that's good. I don't want to be in hours. I want to be in what unit? Seconds. Okay, so how do I do that? Times so many seconds in 1 hour. How many seconds are in 1 hour? That's 60 seconds in 1 minute. So it's 60 times 60, which is 3,600. Now look, guys, at this point in time, what am I now in? I'm in seconds to go feet. Think about what is the one rotation on the Ferris wheel? What do we call that on a circle? Circumference. You need to think about circumference.
Isn't that just like 2 pi r?
And I'm going to pass out the other one. We may not go over that last part of this until next week also. Here's the crazy homework over the weekend. I don't want you to spend any more than 30 minutes on this. If at 30 minutes you're not done, you put it away. Okay? If at 30 minutes you're not done, put it away. Here we go. I'm going to read this to you guys. This is a beaut. Here we go. Are you ready? People hate Ferris wheels, so what did I do? I decided to instead make a word problem with a water wheel. Yes, a water wheel. Here we go. This, listen up, guys. This was actually a quiz one year. Yeah, I know. I hated that class. I wanted to put them in their place and let them. They were like hiding, like, oh, we know everything. I'm like, okay, let's see if you know everything or not. And then I didn't count it, but I told them it was a quiz, and you should have seen the heads when they walked out of this room. It was beautiful. All right, here we go. Dr. Evil, the evil Dr. H2O is at it again. He has just built a very large water wheel outside his lab on the banks of the Sinusoidal River, which is 85 feet deep at the bank. The center of his water wheel is 12 feet above the water level and has a diameter of 68 feet. Dr. H2O takes his arch enemy Molecule Man and shackles him on the water wheel at a position that would associate to 3 o'clock on a watch. He then gives his wicked moo-ha-ha-ha laugh and flips the switch to start the wheel into its counterclockwise motion. Dr. H2O quips, enjoy your swim, just as Molecule Man is at the 12 o'clock position. At this time, Dr. H2O remembers to start his stopwatch. 66 seconds later, the water-drenched Molecule Man makes it back in front of the grinning Dr. H2O at the 3 o'clock position. Holy natural elements. 1. Sketch a graph, and I do want a graph. Sketch a graph that shows Molecule Man's height compared to the surface of the river as a function of time. X-axis is the time as on the doctor's stopwatch. Please show his first trip around the water wheel. Label both the X and Y axis. First things first, do not make the bottom of that graph 0. You have to go underwater. So your water level has to be somewhere up. So your x-axis is not the bottom. Okay? 2, write the function for this. 3, Dr. H2O stops the water wheel when his stopwatch reaches 2 minutes, 22 seconds. Feeling extra evil. He restarts the wheel when his stopwatch says 2:42 and waves to Molecule Man as he reaches the 3 o'clock position. Above, so where you're at, above, sketch Molecule Man's position above or below the water from 66 seconds until the 3 minutes, 16 seconds. Then number 4, this is the best part. Molecule Man's sidekick, Electrolysis, has watched the entire tragedy from his location on the other side of the river. He notices the power line running across the river supplying the electricity to the water wheel. Wanting to save his friend, he breaks free from the rope finding him and climbs up a utility pole to cut the power line to the wheel. Unfortunately, when he reaches the top, he cannot see the wheel because of the trees. Having started his stopwatch when the wheel started moving, he uses the trick he learned in Centerville and decides to cut the power when his stopwatch reaches 9 minutes, 1 second to save Molecule Man from drowning. How far above or below water level is Molecule Man when electrolysis cuts the power? And if electrolysis did not succeed, how much longer should he have waited? Yeah! This was like a different level. All right? This is beautiful, guys. This is beautiful. I love this. Have a great weekend. Again, 30 minutes and no more on this. At 30 minutes, if you're not done, I don't care. Just come back. Okay? But if you come back with a blank paper and you couldn't do anything in 30 minutes, you're doing the whole thing on the board.
I know it's
Passenger board there. So it doesn't say they were the last people to get on there. So if you're the last person to board the ride, you're at the bottom. You're starting at the middle. It doesn't say they're the last. I also know that because if it takes 52 seconds for full rotation, it would take 22 seconds to go from the bottom to the top. It only takes them 14 seconds, so they can't be on the bottom.
Okay. I was confused because I thought then.
So they're starting over here, okay? You're right. So they're starting right in this area. So how long in time? In 14 seconds, they'll reach the max. That 14 seconds is going to put me in a max. That means that's my phase shift. To write it as a cosine function with the maximum.
It was just confusing because I thought when they were starting up there and that's 6 feet.
Yeah, this part here, you don't have to know what their actual height is here to do these functions. You just base it upon, you could base it upon this. You could have said in 1 second they'll be at the midline.
Yeah.
And write it as a sine function.
I mean, I bet
instead.
everyone.
Okay, your choice.
That's where you got one. Why did you just say that?